As the slide, the opening slide says already, I presume everybody knows who I am, right? I've been involved with TM1 for, 18 years now, directly, and Manny gave me the title Keeper of the Holy Scrolls of TM1, so that's what I try to use, because that's probably generally, what I'm trying to do at IBM anyway. It goes from still developing to architecture to all kinds of other stuff, and things like presenting here. So OLAPLINE invited me and asked me if I could talk about, obviously, the TM1 server, or TM1 service, as I like to refer to it now, with the latest edition, V12, and talk a little bit about the roadmap, effectively, and what's there now, what's there in the close future. Some of it has been there for quite a little bit already, but only available on the cloud. So we'll talk about that a little bit. So. My intention is to go do a quick intro. So if you've heard me talk about V12, I might sound like a broken record here for a second, but still to remind everybody of what it is. Do a quick architectural overview and some comparison with the different environments. Recap on some differences, and ultimately get to talk about what's new, what's new in a sense of what's interesting and new, and then go to a demo. And for the demo, OLAPLINE asked me to specifically focus on two things, and that's what I'm trying to do. So build a demo specifically for that, and we'll go over that. And that gets tacky, literally going into looking at some code and stuff like that. So without further ado, one quick question for a start. Is there anybody that has played or worked with TM1 V12 already? I know there's one person in the room. Two. All right, two persons in the room. I forgot about you, Marius, sorry. Of course you have. So it's been available as part of Planning Analytics as a service on AWS since January of last year. So it's getting close to 2 years now. It's been on CPD as well since mid last year. I forget which version number it was, CPD 4.5 or 4.6. So it's been out, but only in those packaging, right? So I'm not too surprised that not too many people have been working with TM1 V12, right? But high level, what it is, it's the modernized version of the TM1 as a service redesigned for a cloud environment, so more cloud-native infrastructure support, which means containerization, but it also means it doesn't have to run in containers. It's just that's one of your deployment options, right? So it still runs natively on Windows and Linux as well. There's two versions. It comes in with built-in support for high availability and failover. That was the biggie, right? So if you run anything on cloud, you don't want to lose what you're doing, right? So it had to be resilient to anything that can happen in a cloud environment. You think a local box is hard, a cloud environment is way harder to run in, because you have things like Kubernetes that decide that your nodes are moving to a different box, or all kinds of other environmental things that you have to now take into account. So that was the biggie for TM1, and where we spent a lot of work on for TM1 V12. It has support for horizontal scaling. I don't have a slide in here, but we talk specifically about high availability. But high availability, you can run in a mode where there's multiple replicas of the same database under the covers. And when I say database, that is similar to what in V11 is a server, right? So one TM1 database. You can have multiple replicas of that same server, which means that for failing over, if something catastrophic happens to one node, the users don't really notice it, because the other nodes will take over at that point in time. And if you run in that mode, the queries are actually sent to all the nodes that are running that database, which means you can have more users using the system with the same database, throwing more hardware effectively at it. And then from an observability point of view, right, it integrates with everything that's typically available in these clusters for metering, monitoring, tracing, et cetera, et cetera. So it does that too. But at the end, it's still the same TM1, right? So the core has not changed. It's everything around it has changed, not the core. So quick high-level overview. Don't want to go into too much details. The big blue box is TM1, the service. And so logically, there's a lot of little services that are running in there, right? And they all run multiple replicas of them. That's what I'm trying to depict with the boxes, right? And then the individual databases are ran as separate nodes in there too. But clients only interact with the big blue box, the TM1 service, right? And so it needs a replica set. It stores stuff on network file storage through PVCs and stuff like that. I'll spare you the details. That's all there. And then just to give you an idea of what that means for the local version, right, of TM112, right? Well, you see there's not that much of a difference. It is actually, especially if you're running on Linux, because the containerized version is Linux. On Linux, it's the exact same services, just packaged differently. And the only difference that you might have noticed is that I had here TM1 service here. And now I have TM1 SD.exe there. That is literally the only difference. There's a little TM1 SD.exe. The name is obviously chosen specifically because it's the same as the one in 11, which is the daemon that starts the services. And after that, it's everything same. It has failover. So if any of these things that are running under the covers, tumble over for some reason, it will auto restart them as well. So failover is guaranteed and built in, even the local version of TM1. The dependency on Mongo, by the way, is for the databases is going away in both versions in 12.6, which is likely to be Q2 next year or something like that. So we will have way less dependency there as well. And then obviously, we store stuff on local disk as opposed to on a PVC, and you can still integrate with all these things, but it's not a requirement. You can have your old-fashioned log file equivalent with the local install as well. The major differences between the two versions, if you move from 11 to 12, is how and where we store stuff, right? So the whole metadata now uses a similar format. If any of you have played with the Git integration or the REST API directly, there's this JSON representation of objects. Effectively, that's what we use under the covers now as well, and we store that in a bare Git repository, meaning that we have full version history of all metadata and data in TM1 in V12 already. The content, so on a cluster environment, right, you do not have access to disk any longer, right? So there's no notion of a data directory in that sense for you as a user of TM1 any longer. But you can still have files that are stored with the database. And that's we do through a files endpoint in our contents API, which already existed, has existed for the last 10 years in TM1 already. It comes with backup and restore. And I'm pausing for a little bit because a lot of people don't grasp what that means, right? You might have, copied your data directory, move stuff around, and do crazy shit with it, right? But this thing is just one command, backup, and you get a TGZ file, which is your backup set, which is everything in there, which you can then use to actually come back from a disaster or whatever, but to move it somewhere else as well. You can restore this anywhere where you have a TM1 V12 service running. By the way, I say file URL and S3 there. That's because if it stores it local, the backups are stored locally if you don't ask it otherwise. But we have support to directly store these things on S3 and restore directly from S3. And why is that important? You do not want your backups locally. Because if something happens, you lost your backups too, right? Especially in the cloud, because you don't have access to those PVCs. Right? So if you lose for some reason that instance or somebody by accident killed it, right, your backups are gone as well. Whereas if you have the backup set somewhere else, it's literally 2 REST requests to get your whole database back to the last state of the backup. We did a new MDX engine. The only reason it's there is that it literally, we gutted the old one, we built a new one. The new one is way more efficient and more complex MDX, plus it does null suppression correctly, or empty suppression. In all cases where in the version that you're using, there is still some gotchas. ODBC is externalized. Just believe that that's the case. Not really important, although I'm guessing you're using ODBC as the source in some cases, but you can still continue to do so. It's just technically different. Property cubes are gone. We consolidated execution logs. That might be interesting if you have many processes that execute other processes, maybe even do run processes and stuff like that. In V12, you get one log file which has everything from all these processes. Which also means that even if you do run process, asynchronously start a process, The main process that you kicked off will wait until that is done because it might write stuff in that log. Execute command is gone. Talking about major differences here. Execute command is gone. We can talk about that one, but there's something new that's better, and then there's a glide path there I can touch on, and it's REST API only. So the reason you see this move now to getting rid of Architect and other stuff and TM1 Web next year and stuff like that, all those tools still work fine with 11, even the 11 that's in the 2.1 box, even with 11 that's in the 3.1 box. Don't tell anybody I told you so. But the 12 only supports REST API. So you'll have to get ready to say goodbye to those tools that are not on the modern API. And when I say modern API, we've had this for 10 years. So there's a lot of REST API-based stuff out there. And you saw Apliqo UI obviously earlier. It's one of the examples that's not an IBM one. So I mentioned these things again, like classic stuff is gone, legacy authentication methods are gone. I'll touch on authentication in a second. Currently, other logs are gone in the sense that they're not available, but we do have full version history under the covers. So we actually have more information now than we ever had before under the covers. We just haven't exposed the versioning yet, and we are re-envisioning how we would build a log from that if you guys, if you opted in for doing all the logging. ODBC support, right? Mentioned it. It's through a REST endpoint, which you can install anywhere, and it doesn't need to be just ODBC. It could be JDBC, or as another partner here in Germany has done for SAP, for example, and stuff like that. So there's more opportunities there. Cube save data and save data all are gone, literally because you don't need them anymore. In a clusterized environment where for high availability, we need what's on disk from a consistent version, so we can't have you store one cube and not save the other cube, for example. But with the changes that I was mentioning already for in next year in 12.6, we are effectively have everything persisted on disk as things happen already, when we get rid of that Mongo dependency. So there's no need for save data all anymore either. Data access I mentioned, execute command I mentioned. Okay, yeah, and then some old stuff. If you know still, well, Java TI is still maybe something that somebody has figured out to use and do. That's gone. But if you still use wrap and sync, anybody? Good. Or bulk load mode. It might be people that have not heard of parallel interaction, which has been there for 12 years now, I think. You don't need this old stuff anymore, that's what I'm saying. So it's in V12, that's all surgically removed. So what's new in TM12, and I have a bunch of slides of some of these where I'll go into a little bit of details, is, so first up, I said files, you can still have store files with the database, and they will continue to act as before. So if you have a process that loads from such a file, as long as it's using a relative URL, so relative to what your data directory was, will continue to work, and we'll find that file, and that's fine. But everywhere where you use the file as the data source, or you write to a file with ASCII output or text output or something like that, you can now use a URL as well. And what that means is that you can just literally read from anything that is URL addressable, which could be a service that generates content on the fly. So it doesn't need to be a file anymore. It could be a Lambda that is a serverless function that runs somewhere that grabs data from some other service, converts it into CSV and gives it back to TI, and then TI will perfectly happily load that. In same thing, if you text output or ASCII output stuff to a file, if it's now a URL, we'll collect that output and we'll put it. Use put to send it to that URL, which could, again, be a file destination or a service, and that service does then whatever it is what you want it to do with that payload. So way more possibilities there. And if that's not enough, the even bigger thing probably is the fact that we have a framework built in for you to do web requests. So any service out there, effectively, you can now make requests. As long as it's HTTP based, you can make requests to that service. And I'll have a little bit more about that, how that works in a separate slide, and we'll see more of that later. Capability of pushing and pulling data is what I effectively already said, right? But you can continue to use that ODBC style interface, which is the ODBCIS service. This is the implementation for that, but you could do your own as well. That's also an extension point. And I mentioned the file content endpoint already that we had already in 11, but in 12 it comes with multi-part uploads and partial range-based downloads, which are standards. Multi-part upload is a standard that S3 introduced. We follow exactly the same pattern. And partial range-based download is actually part of the HTTP standard, so we installed as well. Meaning you can split up a file, for example, and upload it in parallel and bring it together again. That's multi-part upload. But the same way you can say, you give me the first 1,000,000 bytes from this file, the second 1,000,000 bytes of this file, in parallel as well when you download stuff. So transfers can be made faster that way. We have asynchronization functions for jobs. So what's a job? Well, in TI, the only job we currently have is run process. So run process creates a job under the covers, and that job we have now asynchronization functions for. I'll get back to that one, and that will be part of the demo as well in a bit. We have TI functions to deal with JSON data. So the big missing thing was when we introduced it 12.0, the ability to do web requests is, most web services or services you might be wanting to call, you either have to pass a JSON or it returns JSON. And since everything in TI is a string, right? And JSON, you get the stringified JSON, but it's very hard to do anything with that in TI as it is. So for that, we introduced that, and I'll talk about that. And we added JSON as a data source. I'll get back to that one too. And we added support for session variables. Session variables is an interesting thing. It's think about it as an environment variable, but for a specific session. And in a service-to-service environment, which now TM1 plays a role in, right? In a service can call TM1, create a session, and pass it pieces of information, like API keys, tokens, credentials, and other stuff, so that a TI can use these and make requests to other services again, knowing the API key it needs to do so on behalf of this user, or credentials or whatever that is needed to do so. So that's what it is intended for. And there's more utility functions around that, like base64 encoding support, JSON tokens, validation and creation, et cetera, that we added. Security, I mentioned it briefly. In a service-oriented environment, typically services authenticate to each other with a service-to-service authentication. Meaning, a service that I want to have access to my other service, I give it a client ID and a secret, and then it can call me using that client to authenticate with that client ID and secret. And that's as simple as it. So the case for planning analytics, the planning analytics, in any setup, gets a client ID and a secret, and then it can connect to TM1 using that client ID and secret, and then it asks TM1 for a session for a user which is already authenticated when it came into planning analytics. So that's where TM1 itself doesn't do the authentication anymore, because typically it's called as a service and the authentication has already happened, so we don't need to re-authenticate again. Besides the service-to-service, which we obviously use in all our planning analytics as a service setups, we support OIDC and HTTP authentication. Now, OIDC is a standard, so if you ever maybe logged into LinkedIn, Facebook, but there's more generic ones, right? Okta is a very known one, right, which a lot of organizations use. There's thousands of these literally out there. You can set up your TM1 server to allow somebody in that is already authenticated using that security provider. So if you set it up for Facebook, anybody with a Facebook account recognized by Facebook, you're allowing into your system. And the only thing it guarantees that whatever that handle is, typically an email address, is authenticated, in this case by Facebook, if you trust Facebook, to get into them. But it's any of them, there's many of them, right? Azure AD, right, a commonly known one, and probably everybody in the room uses it indirectly or directly because you're using a Windows machine, right? So Azure Active Directory, is one of those OIDC providers, for example, as well, that a lot of people use. And HTTP pass-through is, as the name suggests, right? It's HTTP-based authentication, which is what a V11 server always would have done, right? But in this case, we pass it through. So you configure with a URL which service it is that does HTTP authentication that you trust to do it for you. So you delegate the authentication effectively. So any service will do, right? I've got some sample services out there, but simply pointing at a V11 server will work as well. So then, especially during migration, I know some customers have looked at this to say, okay, I want to keep using whatever I set up there. Maybe it's CAM even, right? Which is officially not HTTP authentication, but if you go through V11, we make it available as HTTP authentication. Just set up one URL and pretty much you're done. So that's what that one's for. I think I pretty much said everything to say about this external resources and using it, right? Instead of a file, you can specify a URL, and instead of it being a file, we'll call the URL with a get if we're reading from it, and we put if we're writing to it. And then it's up to you to be creative as to how you use that, and if you're calling a service instead of a file or whatever, right? So the only thing, if you've ever worried about it or not, doesn't matter. The encoding that we use in V12 everywhere is UTF-8. The reason why it's important is if you've ever moved a TM1 database, so you did that copy and then you restored it somewhere else, and that was a Windows box that happened to run in English and the other one was in German, or German and you moved to English, especially that latter one, your umlauts might be gone or something like that, or your Ringel S's, right? Because the code page is different on these, and they were using their own. So for migration, that's actually a thing as well, at the side. But so in 12, even our Windows-based servers are running everything in UTF-8. Linux UTF-8 is a standard anyway, so Linux is not an issue. Web requests. This is probably the most well, it starts with this, right? People have gotten very creative when it comes to using execute HTTP requests already, because now the world of services out there is, at your fingertips. Anything and everything that's available as a service out there, you can now do something with in TI. So if you ever played with a tool like curl, or you did web requests in JavaScript or in Python or whatever, right? This is the equivalent for TI, effectively. So it's there's a whole slew of parameters you can pass it, right, to do all kinds of requests with HTTP, execute HTTP request. And if the response is huge, anything bigger than 100 kilobytes, you can actually flush it to, or anything smaller as well, you can flush it to a file, which you then can subsequently use as the data source in your TI as well. So there's all sorts of stuff. And I have, my demo is going to use this one too. The other ones are all supporting functions. So once you did a request, right, you can find out what the status code is that it returned, right? Which typically you want to know if it's a 200 class status code, right? If it was successful, you can get information that was returned in a header of a response with the response get header. Obviously, you can get the payload. If you didn't push it to a file, then there's a string that will contain the payload, and then there's an auxiliary function to do URL encoding. That's the only part you probably need to understand if you've not worked intimately with the URLs yet, right? The encoding of individual parts in a URL, how to do that at the right point and stuff like that. Because there's certain characters that have meaning in URLs and they have to be encoded. Jobs management. So run process, right, has existed for quite a while, which effectively says, okay, start this process and then, forget about it effectively. It runs to completion or not, you'll never know. We've wrapped that in a job, the notion of a job, and you can now start waiting for those. You can wait for any job, meaning you specify a bunch of jobs. If one of them is done, the function will return and tell you which one it was that was done first. Wait for all jobs, as the name suggests. You can specify, again, a number of jobs, and it'll wait until all of them are done, right? The wait for internal jobs is a little bit special because in some cases you cannot know the job ID, or you did an execute process which did a run process. Then we can't still in TI not return information to using execute process, right? So we wouldn't know what the job ID is, and for those cases, it's like, I want to wait for anything that's executed being done. That's what the wait for internal jobs is. So you don't have to specify the job ID. Get job status, I think the name says it all, right? Although I think in retrospect, in the tradition of TI, this should have been named job status get, but too late for that one. So get job status returns the same statuses that you would have gotten from execute process, but it might also return process execution in progress, because it might still be running. So there's an extra status in that case, in which case you have to wait longer and then, you ask for it again. Typically, you would do it the other way around. You would say, wait for any jobs, and you specify the job, and then you ask for the status of that job, right? Then you know if it succeeded or if it returned errors or it had some minor issues or whatever. And cancel jobs, as the name suggests, right, will try and cancel the job. Same thing as what you would have traditionally maybe done in TM1 top or whatever, right? Trying to cancel shit. It's like JSON functions. So, I'm not sure if anybody has tried to parse JSON in TI. That's pretty much impossible unless you really, really know exactly what the JSON is that you're getting back. I'll give you the slides later, by the way. You have that. But this makes it super duper easy, right? So JSON type, and you give it the string, the variable or whatever where the JSON is in, it'll tell you what it is, right? Is it an array? Is it an object? Is it a string? Is it a boolean? Is it a null? Is there something else? Or a number, or an integer, or a floating point value, right? JSON size in the case is 1 for normal values, and it gives you the size, a number of elements in an array, or the number of properties in an object or a map, right? You can then iterate through those. Obviously, if you know how many there are elements in an object, in an array, or how many properties are in an object, you can get the values with JSON get. And for an object, you can actually get the names of the properties by JSON get key, right? The X key of these things. And then we have a bunch of functions that will allow you to manipulate and build, change, manipulate JSON. So JSON add, remove, replace, move, copy are all permutations of that, right? Add is obviously the one that you might end up using the most. I'll be using it in the example, but you can copy stuff and stuff like that if you need stuff more, and then maybe patch it afterwards and stuff like that. Because that's patch, diff, and merge patch are exist well. If you know how merging and merge patching and stuff like that works in JSON typically, right? It is like you'll be used to in what Git does, right? Or if you try to do a diff between things, it tells you what the differences are. If you apply that diff to an object, you get the other object again. And so the same thing happens here. So you can make sure that if a value didn't exist, you add it, or it existed, you override it with a value, and all that kind of stuff. So pretty strong set of functions. Anything pretty much you want to do with JSON, you can now do in TI with these functions. The last one is important in the sense that if you know you're dealing with JSON, then it's always JSON, and the JSON representation of something. Strings, since the JSON is in a string in TI, and a JSON string are two different things. The difference being there's quotes around it, right? So a JSON string is the string with quotes, and obviously the string that you want to use in TI is probably the string without the quotes. So that's why there is a JSON to string, which effectively gets rid of the quotes if it is a string, and vice versa, string to JSON. You have a value in TI that is a JSON, that is a string, it'll put quotes around it and make it a JSON string. That's what these are for. So you'll see them in my demo later on, left and right as well, because the notion rule changing between a regular string value and a JSON that represents a string is that difference. And then JSON as a data source. As I said, right, so most services will actually return, or you have to give it JSON or return JSON. So If you want to, if it's a large JSON, then you do not want to deal with that in a string, apart from the fact that strings are still limited in TM1 or in TI to a certain size, right? Almost 128 kilobytes. So instead, if it's a data source, we will actually iterate through the data source, the JSON document, and then in the metadata and the data tabs, right, give you every instance of what you're looking at. Typically, what you're iterating is either a collection in the source, or if it's what we call concatenated JSON, meaning a file with many little JSON documents, effectively, they might be new line separated or not, then it's every document in that JSON. And then we have a mechanism that says, you can do a variable mapping. So for every record that's in either that collection or in the concatenated JSON, you can tell us which part of that JSON you want to be mapped into a variable in TI. And those variables then are available in the metadata and the data tab as normal. Keep in mind, though, those are individual JSON values. So even if it's just a string, it's still a JSON string, right? So this is where, if you have a cloud data source, right, or a database somewhere in the cloud which you can ask, run queries against, and which returns stuff in a collection of JSON objects, for example, this is what you can use then to immediately load that into TM1 through TI. I mentioned this one. Effectively, the environment variables, as I said, for a session, there's only one function, session variable get, right? You cannot manipulate those. They like environment variables. They're fixed, but you can use them in TI. Demo time, and I'm still on my own schedule that I wanted to be. So this is where we are going to be a little bit more geekier. First up, I'm using the local version of TM1 v12. Now, I'm too lazy to set it up again on this machine, but just to give you an impression, I have a version of TM1 12 installed. This is the install directory of my v12. So if you ever seen an install directory of TM1 11, which I'm sure all of you have, right? It's a big pile of stuff. In TM1 12, that's much neater and cleaner for multiple reasons. So literally in here has, you remember the architecture slide I had, right? There is literally an async service, an authorization service, a batch handler, a daemon service, a gateway service, a publisher service, and TM1 SD, which is the wrapper service that kicks these off on, in this case, Windows. Equally works the same on Linux. And then there is the traditional TM1 folder, which has a Bing64, which is also almost empty nowadays. It has the TM1s.exe and TM1s run.exe. The run is actually wraps the TM1s because that's for backup and restore, because we have to actually recycle the process at that point as well. So it's the wrapper process that deals with that case. That's pretty much it, what we have on here. So I have, and here's some additional that we provide you with. So it still has the dependency on Mongo, so it installs and starts Mongo batch script, and install it as a Windows service or start it as a process on the box. Now I did, as you can imagine, I installed TM1 12. IBM TM1 v12 standalone service, so it's just the Windows service, it's just running locally. There's no containers anywhere here. Docker, never heard of. Just like you had a v11 server, effectively. The only difference is, the main difference is, if you remember the architecture picture, this service deals with all databases now. So unlike before, I know there's customers that have many TM1 SDs in here as services for each and every database that they have. You don't need that anymore. Now you have one service, and you talk to that service, and it manages the databases for you, which is effectively what we're going to start and use. So it's clean. I cleaned it up completely to do the full demo. So this is exactly so the only thing I did was actually set it up for HTTP authentication, which I did my gimmicky server. I can actually quickly show that as well. Not this one. So if I go to TM1, I actually installed it locally, TM1 server 9090 active user. It says Anwendertreffen at example.com. And so right? And so what I did effectively is say, anything that is at example.com in this service and knows the magic password, Apple, and then you're good, right? You're allowed in. You're your friend. You know what you're doing. You're in, right? That's what this service does, and that's the one that I've set this TM1 service up with. As you can see here, this is that URL and the endpoint. In this case, active user. You can write your own, and this endpoint can be anything, right? And as long as you can define where the name of the user is in the response, you're good to go. So, having done that, it's completely blank TM1 service. So I'm going to create an instance first. The instance is called Anwendertreffen. So now I have an instance called Anwendertreffen, as you can see. And so now I can start in this namespace, you call it, or instance, or whatever you want to call it, right? I'm going to create a database, and the database is named, sorry, I show you there's no databases, I should say. And here you see cookie, right? And so this is the same cookie, similar cookie is in 11, and I've actually logged on with this username, which is in this case hubert@example.com. Remember, I used that service, and obviously the password is Apple, as you can see. Right? That allowed me in, and that will allow me to create a database. That'll take like 10 seconds or something like that. So that's it. So again, this response looks exactly the same as it would have looked if you would have been on the cluster. The only difference is that it doesn't care really much about how much memory, because your box is the limitation here. But it has one instance, and it can only have one, which has the role of a leader. Remember the leader follower, if you're running in high availability, you cannot do that if you're running local. Local, you can only have one instance. And there are physically otherwise no limits. So you just created your own new TM1 server and done everything that's needed to do in the background. It did this for you now. Now, to have some fun, right, this is an absolutely empty server, obviously, there's nothing there. So let's just create a couple of processes quickly. I just put that in there. And these processes, because there's not much here further on, I'm going to use Arc. Why are you smiling? It's like it's a great tool. No, I don't have PA local, so not on this box. So I'm going in here again. I'm going to log in with my hubert@example.com and the famous Apple, and then you can see there's nothing here, no dimensions, no cubes, other than these processes. Now, this is where I want to start talking a little bit, and we're going to look at these processes. Because I want to go a little bit in depth on using the JSON functions, JSON data source, and the job synchronization stuff. And I deliberately wrote this sample to do exactly that. So don't take this as production quality code or something like that you can use. You can get inspired maybe, but just to show off these new capabilities for TM1 12. So what I did is I started with providing it a service root URL. So what I'm going to do, so just to outline this a little bit. Actually, I should have shown you actually I can show you here. I have actually locally also, this is the V11 mini as data, minimized as data, which has a bunch of dimensions and some cubes, right? A couple of cubes. So a minimized version of the as data model that you might know as a sample. That's what I'm using. And so my goal is what I want to do, and this is, I'm not saying don't try this at home or something like that. I don't think this is the best way to do it. I just wanted to show the functionality, so that's why I did it. So what I decided to do was use the REST API of TM1 as just a REST service out there, right? And get information from it and use that to create objects in 12. So what I literally am going to do is going to copy the structures of the cubes on the 11 server to the 12 server, only using JSON as a data source, JSON functions, and these synchronization functions in TI. And that's what I'm trying to do. So what I did, this URL here is the service root URL to my V11 server, right? So that's there. And if I would go to my V11 server directly, right, in a browser, then you would see that if I do slash cubes, right? You would see that I have this price cube, sales cube, and then all the curlies. Forget the curlies for a second. So these two are the two, right, that you saw in the in Arc as well, right, that I want to structurally copy to my V12 server. And these have dimensions, so the dimensions I have to create on that V12 server as well. So what did I do? So I created this first TI, and this TI is using a combination of things. So on the top, I have, for starters, the execute HTTP request, where this variable, the resource root URL that I just showed as a parameter that I pass into this this process, right? I concatenate /cubes, which is what I just showed into the in the browser, right? And I say, well, I don't need everything. I just need the name of the cube, the rules, and I want to know the dimensions that are in this cube, right? That's what that request says. And I just log in as a user admin, no password, because it doesn't have a password in that one. And the output, actually, I said, I want to have to in JSON, right? In JSON. Actually, that line is not even needed, to be honest. Then on the next line is the next function that I told about before. It's the HTTP GET response or response GET status code. In this case, I'm expecting a 200 OK response, right? So yes, here it is, right? So if it's not 200, I process error and go out, right? But trust me, it doesn't. And then this is where the first line I'm going to use, where I'm actually getting the information of that document, right? So again, the document I'm parsing is this portion, right? This is what I'm getting back from that server. And so what I'm saying here is JSON get everything that is in /value. And /value is a JSON pointer, and which says relative to the root of this, which is an object, right? Give me value. So after that, I'm already got rid of anything else that's in there. I only have the array left that has the cubes, effectively, right? So the value in here, this value, effectively, is what I have left as an array, right? That's what's left after that comment, command, yeah. And then I'm cheating a little bit because I'm also setting this up to use, synchronization later on. So I'm actually going to introduce a quick couple of variables here that have job IDs in them. So forget that for a second. But what I'm going to set up here is, you see this JSON dimensions, and I do quote, curly brace, quote. Well, curly brace is an empty object in JSON. Think of it as an empty map at this point in time, because I'm using it as a map. And then I'm going to ask, I'm saying vcubes. So vcubes is the JSON size of JSON cubes. And JSON cubes is what I just got from this value. So I have the collection now. So this gives me the number of elements in the collection, which in this case is 2, right? Sales cube and price cube. And then I'm going to iterate through this. So I say while I have an iterator number, right? 0 is less than the number of cubes. I'm going through these. So now I'm going to say, grab me the dimensions. I'm doing this through a JSON get from this cubes array. But the JSON pointer I'm going to give it is / a number, the xth element in that cube, / dimensions, right? Again, looking back at that response, this response doesn't have it. Hold on, let me do this. $select this. So as you can see here, right? So price cube, there's a dimensions in there, and then I have in this case four dimensions in this 4 dimensions in this cube, right? So in this code, what I'm grabbing here is those dimensions. That dimension structure for that particular cube. And then I'm asking it, how many cubes are there? Or how many dimensions are in this cube, right? Cube dims is JSON size, again, the size of the array. And then in there, for every of these dimensions, I'm grabbing, again, from this JSON structure, the name of the dimension, right? So again, in the array, relative, the xth element, I'm grabbing the name for each of these into a string. And this is where you see the first time JSON to string, because otherwise the quotes are around it. So I have the dimension name now. And then I do something nifty here. I say, I'm checking in this JSON dimensions that I just created here as a map, which is empty, right? I'm checking if that dimension name is in there already as a property or not. So I'm now actually using this as a map. So I'm telling you actually that with these JSON functions, even if you don't use the data source or any of the other stuff, you now have objects, maps, and arrays in TI, which you can use for all kinds of other stuff as well. So I'm checking if it's in there. If it's not, then I apparently haven't started a process yet of creating that dimension, right? So I can then do, the job ID is run process, right? I'll show you in a second, a copy dimension JSON process. I pass on the URL again, right? And then which dimension I want to create. And so that kicks off the process, doesn't wait until it's done, just kicks it off, right? You have the job ID. So in my map, I'm now adding that job ID as the value associated to a property that has the dimension in. And then this is just trickery, forget that for a second, and I'm going to the next dimension, next cube. So what happens now is that when it iterates through the first cube, the price cube, I think it is, it finds these 4 dimensions, looks at each of them, not in the map yet, starts up run process to copy the dimension, and then does the same thing for the sales cube, which has an additional dimension. Skips 4, because those are already loading, and only the one that hasn't started loading yet starts off this run process again. So at the end, I have 5 parallel processes that are copying dimensions, 5 in parallel. This is just jiggery to keep those job IDs, because what I want to do after that, if I go down here, I'm going to say, wait for all jobs. So this is the point where I say, okay, now I want to wait until all these 5 separate, I know it's 5, so I'm cheating here, right? Where all these 5 are done. And once they're done, which I could have done with wait for internal jobs as a hack, so I wouldn't have to keep track of these job IDs. I just wanted to show how that works. This would have done the exact same thing. Once I'm done, I know I have the dimensions, so now I can start creating cubes using those dimensions. And that's what I do here. So, and again, I had to use some trickery here because I'll tell you later on what I am looking to do in the future here. But at the moment, right, I have to pass in the names of the dimensions as parameters. So I need to know how many there are. So if there's 4 dimensions, I'll use the cube name and then say, grab me the name of the first dimension, the second dimension, the third dimension, and the fourth dimension. And the same thing for a 5-dimensional cube. Grab those names from these individual dimensions in there, and then just create the cube. And then, oh, by the way, if there are rules, which I had in my original payload as well, set the rules as well. Just in one, and this is the whole process. I'm going to do, look at the dimension copy function. As I said, pass on the URL. This is actually a very simple one. I just presumed there's only one hierarchy, so I simply call copy hierarchy. But we have to look quickly to the copy hierarchy one, because this is the one that is actually going to use the data source. So I'm using add here again, making a variable mapping. I want the element type, the element name, and any components that it has, which is called edges in the REST API. I'm saying the data source type is JSON, right? The pointer mapping, so I want to grab from the response the /value, again, that array that I did in the first one too. And this is the variable mapping, these 3 variables that I created. And again, let me quickly show this. There is these 3 variables, right, that I created, JSON element name, JSON, each of them, right? And then I'm just saying dimension create dimension, right? That's what it does. And then in the metadata tab is where the magic happens, right? I'm going to say, okay, now I have a JSON element type variable. I go to string, compare it with numeric with string, so it's an NS or a C, right? And I do a hierarchy element insert, right? And then I know, because I cheated, the order in which I have the elements, so I know I have the children before I have the parents. I can do this immediately as well. If there's any edges, similar logic, what's the size, how many are there, and as long as there are there, hierarchy element, component add, and still JSON to string, the value, and the component name. The component name is actually in the edge information itself, so I have to do another JSON get of the on the edge component name, which is the name of the component that is being added. And I actually grab the number value of the weight in there as well. And that's it. So if I do all this, I'll start it immediately from here. So copy cubes. If I now execute this process, which I'll call execute, and I refresh here, you'll see now that in my V12 server, I have 2 cubes, and I have 5 dimensions, each of which have their complete structure copied and created in here in the V12 server using these JSON functions. And even my rules and everything are brought across as well, in here as well. So I hope that gave you an impression on how to do web requests, how to do job synchronization, how to use JSON functions to do anything with JSON, and how to use JSON data sources. Forget for a second I was actually using a TM1 server as the source, but any service you can use that gives you JSON structures you can use and consume now in your TI. So if you haven't already, right, start looking at 12. Right? The 11 life might be prolonged a little bit because we still say that we officially support it with 3.1, which we're introducing early next year, right? Get off it if you can. The local version will come out. That's your step to eventually going to a cloud infrastructure if you need that intermediate step, if you can't go to cloud directly, either locally or on-prem. So that's this, stuff that you have involved is actually what I said. And this is a list of what's brewing, and I just quickly want to mention it. So we're still working on that new consolidation engine, the new heart of TM1. We're going to do the hard replacement at some point. And there's a whole slew of stuff that we're doing with regards to making more data available in more ways and more efficient ways for integration with other tools as well, which is a whole bunch of these things that I have here. And I'm working on, I think the other important thing here is I'm working on a new extended TI language, which is backwards compatible, but which will have arrays and maps and functions and lambdas and all that good stuff built into the language, as well as a lot of syntax improvements in the language as well. I think that's it, pretty much. Thank you very much.